Daddy, what are you doing?
I'm making a mask.
For who?
For you.
Why? I stay at home all day and stay away from the coronavirus.
I know. That's why I'm making a mask for you. You talk too much, and it is so distracting. I cannot work from home.
Hi, this is Dr. Xu, teaching mine ventilation for mining engineering students. Today is March 28th, 2020. Recently, there is a great mask shortage due to the novel coronavirus outbreak. The confirmed cases in the United States are 124,000 as of today. Most people are working from home and we are working really hard to get through this. Masks are also commonly used in mining-related works. So today we will talk about masks. I will use this N95 respirator mask as an example. When you wear one of these masks, you need to fit in between the edge of the mask and your face. So here, everywhere here. Make sure air won't leak at the edges. This is because if there is any visible gap between the mask edge and your face, the resistance through this airway is going to be much smaller than the small pores in the mask. Assume this mask has 90% of filtration efficiency. If you don't wear it properly and you have gaps on the edge, although the gap is pretty small, but study has shown that with that gaps, the filtration efficiency is going to be only like 10%. Pretty much like you are not wearing anything. We know that air, like other fluid, prefer to flow through a channel with small resistance instead of high resistance. Most of air you breathe will pass through the gap without any filtration and protection effect. If you have beard or mustache, make sure you shave them clean so you have a smooth face. Otherwise, there will be many gaps between your face, the beard, and the mask, which substantially reduce the mask filtration efficiency. Now, let's say there is a perfect seal between the mask edge and the face. How about if I make a plastic cover with a small hole on it? So you have a plastic cover here. And there is a small hole here, and you can cut one piece of the mask and fit it into the hole. So put that mask material here. This way, one mask can be used for many times as we only need to replace a small piece of the mask material and we can keep using the plastic part of the mask. It is definitely a good idea, but generally we don't do that. Here is why. Let's assume the small hole on the plastic facial cover is 1/5 of the original mask size. So this size is 1/5 of the entire size of the original mask. This means we can cut the original mask into 5 pieces and use them for 5 times. You can cut this mask into 5 pieces and put it into this little hole so you can reuse the plastic part of the mask. Now, in a situation like now, we're running out of a mask, probably it's a way to save mask materials. In the real mask, there are many small pores that creating the filtration effect like this. Assume the resistance of each small pores in the mask is R. So the resistance of each of the small pores is R. And the number of such pores is N. So we have N number of the pores in total. The number of the pores on the small piece here is going to be N divided by 5 because the size over here is 1/5 of the entire size over here. So here the number of pores is N divided by 5. And each of the pores, the resistance is the same. It's going to be R. These small pores are parallel to each other. Therefore, the resistance for the whole mask can be calculated using the equation R equals to 1 divided by square root of R1 plus 1 divided by square root of R2.
plus 1 divided by square root of Rn square.
Because in this example, R1
equals to R2 equals to Rn equals to R, we can reduce this equation. The R is going to be R divided by N square. Over here, the resistance for the small piece is going to be, this is the R modified equals to the resistance for each pore divided by N divided by 5 square equals to 25 R divided by N square.
So the resistance for the small piece is 25 times more than the whole mask.
That is because Rm equals to 25 times of R.
According to the square law,
P equals to RQ square.
Q is pretty much constant for human. We need a fixed amount of air per unit time to be normally functional. If the resistance is 25 times larger, that means we will need to breathe 25 times harder to maintain the same amount of air flowing to our lung. This is a lot harder. What is even worse is when we breathe out, we need to push 25 times harder so the air can pass through the little piece of mask filter. In this mask, it has a little device here. It looks something like this. But there is a little hole and there is a little door. When you breathe in, the hole is closed. So air is filtered by the mask material. When you breathe out, the little door is pushed to open, so you don't have the extra burden to push the air out. This is not a video on designing a mask. I just want to show you how the mine ventilation principles can be applied in other situations, such as wearing a mask. Thank you very much for watching. If you like the video, please give it a thumb up and subscribe my channel. I will see you in the next video.
All done. So there is a hole here, and I put a couple of layers of tissue. Danielle, come here. Keep it really tight. Is it tight?
Yeah.
Tight enough?
Yeah.
Can you breathe?
Yeah.
Breathe hard. Breathe. Okay. Don't take it off, okay, for the whole day.
No, it's not comfortable.
That's fine.
No, it's not fine.
At least it keeps you quiet, okay? All right.